Let's talk paired samples t-tests. With paired samples t-tests, you need two measurements or two variables reported from the same individual. And in this case, what we're interested in is comparing the baseline proportion gaze to the singer with the other gaze to the singer variable. In this case, we're interested in the test proportion gaze to the singer, which is after the baby saw the singer sing, compared to baseline, which is before the baby saw the singer sing. So to find out if there is a significant difference between the baseline proportion and the test proportion, what we'll do is we'll go to Analyze, Compare Means and Proportions, Paired Samples t-tests, and then here you have space for variable 1 and variable 2. We will put the baseline proportion gaze to the singer in variable 1 and the test proportion gaze to the singer as variable 2. Right now, we're only interested in those two comparisons, so we're not going to do any additional pairs. We're also going to make sure that the data file is split, so we're only looking at experiment 1 by going to Data, Split File, and then if it hadn't already been sorted, experiment 1 would be over here, and we would put experiment 1 in the Organize Output by Groups. So we now have our variables entered, and we want to have it based on the standard deviation of the difference. Click OK. And we're not interested in this one. We're interested in experiment 1. So up here is our table with our descriptive statistics. We can see that the mean for baseline gaze to the singer is 0.52, and then the proportion gaze to the singer is 0.59. So that is a difference of about 0.07. Our standard deviations are similar here. They're both about 1.8, which means that the difference in those means is a little bit less than half a standard deviation. That is, generally speaking, a pretty big difference in most psychology studies. We don't need to be concerned with the correlations. This is just for our information. Not surprisingly, the more a baby was looking at the singer at baseline, the more the baby's looking at that particular singer after hearing a song. So the more they look at somebody, the more they look at somebody. And what we see here with the paired samples t-test is here the mean difference, which is 0.07 and change, which looking up here, we can see the two means, and using estimating and rounding, we can tell it's about 0.07, and it's about 0.07. The standard deviation of the difference is about 0.17. We can see that the 95% confidence interval of the difference, the lower and upper, are on the same side as 0. And that is a sign that this will be a significant difference. Similar to not having an overlap in 95% confidence intervals. If the lower and upper do not include 0, then that shows that it's statistically significant, which with a t-value of negative 2.416, you can see, looking over at the two-sided p-value of 0.022, that this is indeed a statistically significant difference. We have 31 degrees of freedom. Our sample size is 32. We lose a degree of freedom anytime we conduct a test. So this is a statistically significant difference. We would have T with degrees of freedom 31 equals negative 2.42. P equals 0.02 would be how this is reported. The T value is negative here because the first value that we entered is smaller than the second value we entered. So it shows the direction of the comparison. If we had entered those values in the opposite order, let me show you here. So if we had gone analyze, compare means or proportion, paired samples, t-test, and we'll put that one back, and we're going to put in test proportion and then baseline. Everything else is the same. Click OK. Then we see that we have the same t value now, but it's positive. Now let's graph these. We'll go over to graph, and then we're going to use bar graphs. So bar graphs, we're having simple. We are comparing variables here. We're comparing the baseline gaze proportion to the test. So groups of cases are when you're comparing individuals, but we don't compare individuals in paired samples t-tests. We compare variables. Click define. Our bars are going to represent baseline and test. And then under options, we're going to want error bars, but we're going to want them to show one standard error. This allows for eyeballing significance. Click continue and OK. Again, we don't need to be interested in that first one. And here we are. Now, if you want to change things, if you click on them, then chart editor comes up. We can have this be rewritten by typing in different text. Doesn't seem to want to let me type. There we go. It's just got to get the right amount of clicks. So we can type that out and write experiment 1. And then I think that's too small. So let's go back here. We're going to make the preferred size 20, minimum size 18, apply. There we go. You might also look here and think that is a lot more zeros than we need to see. Double click on the y-axis, go over to scale. We got minimum, maximum, custom text, major immigrants, labels and text. I'm not quite sure why it is showing so many zeros afterwards. Number format, there we go, decimal places. You know, I think 2 decimals would be sufficient. So there we go. It's under number format. You can also click on the colors, change it here. I'm going to do showgirl theme, get some orange going on. And there you are.